Bismillah ar-Rahman ar-Rahim. We made this video to explain our project briefly. We specially mentioned that this project is under supervision of Engineer Fadwa Al-Momini, and the team members are Muhammad Qawariq as the team leader, Hussein Mizyed, Ali Adnan, Zakaria Al-Jawad, and Badr Hajjar. So we designed a measurement system that measures temperature between 100 to 320 degrees and convert it to a digital signal. We used the TF101N sensor, but why did we specifically choose this sensor? Simply, not only it covers the range we need, but also it uses platinum RTD, which gives better repeatability and stability over long periods. And we cannot forget the high accuracy this sensor provides. Now, we know that in our project we need the sensor to measure temperatures between 100 to 320 Celsius, but actually this sensor measures between -70 Celsius to 500 Celsius. So, we built a signal conditioning circuit to overcome this issue. Now, T0 and alpha equals 0 Celsius and 0.00385 according to the sensor datasheet. We considered R1 equals R2 equals 100 ohm and get R3 equals 139.43 ohm considering the self-heating, which is the resistance when temperature equals 100 Celsius, the 139 ohm, which is also the minimum resistance that will make the null condition. So we put it in R3 to make the null condition when the resistance equal 139.43 ohm. Then we calculate the R maximum when the temperature equals 320 Celsius and we get 224 ohm. Then we calculate the R, the V minimum and V maximum that will enter the op-amp. For ADAC we considered 16-bit ADAC. We calculate V reference equals 1.3107 volt. And we calculate the Vn and Vn maximum and minimum for ADAC to get the RL and RF for op-amp. As we can see here, we have V source equals 5 volt, R1 equals R2 equals 100 ohm, R3 equals 139.43 ohm. R1, R2 and R3 are constant. We have R4, which is the resistance of the sensor, which will vary between 139.43 ohm to 224 ohm. Now, note that we replaced the RTD with potentiometer. We replaced the RTD with potentiometer because we couldn't change the resistance of RTD in Malteser. We have the output voltages of the circuit, enters the op-amp. R6 and R8 are the RF, R4 and R5 are the RL. We have a 16-bit ADAC with V reference 1.31072 and clock voltage. We have the displays here to see our results. Let's begin the simulation with 224 ohm, which is the maximum resistance. We get 4 Fs, which is the maximum number in 16-bit. Let's try the 139.43 ohm. We should have zeros and we already have zeros. Now we are going to try a random resistance. Let it be 180 ohm. as we can see here, 180 ohm give us A to E B. Thank you for watching and hope you enjoyed this video. Peace.